Welcome back to the Deep Dive. I'm your host, and today we're really diving into something quite revolutionary in metabolic science. We're focusing on a peptide that's, well, it's really resetting the bar for treating some major health challenges. It's called Tirzepatide.
That's right.
And its unique dual-action mechanism that's really the core of why it's causing such a stir. It's not just new, it seems genuinely transformative.
It really does.
And to help us unpack all of this, I'm really pleased to have a leading expert in metabolism and diabetes research with us today. Welcome.
Thank you. It's great to be here. Tirzepatide is, well, it's one of those topics that's genuinely exciting. Yeah,
Right.
because it brings together some really elegant, molecular biology with results that are making a huge difference in people's lives. It's more than just another drug. It really shows how understanding our body's own sophisticated systems can lead to these breakthroughs.
Absolutely.
So I'm really looking forward to, breaking down the science behind it for you listeners today, hopefully in a way that's clear and engaging.
Fantastic. And I know our audience, many of whom follow this space closely, are eager to jump right in. So let's start with the basics. For someone who's maybe heard the name Tirzepatide but isn't quite sure what makes it tick, what exactly is it? And, what sets it apart?
Right. Good place to start. So fundamentally, Tirzepatide is a synthetic peptide. And its main job is to act as a dual receptor agonist.
Okay, dual.
Exactly. Now, your listeners will know about incretins. These are hormones from the gut, right? Like GLP-1, which is glucagon-like peptide 1, and GIP, glucose-dependent insulinotropic polypeptide. Normally, these get released after you eat, and they play a big role in managing blood sugar and, energy balance.
Right.
What makes Tirzepatide special is that it's designed to hit both the GLP-1 and the GIP receptors. So instead of just activating one of these pathways like older therapies did,
It goes for both.
it engages both,
Simultaneously.
and simultaneously. And it does so in a very precise and effective way. That dual action is really where the magic happens, so to speak.
So if we imagine the body's metabolic controls like a dashboard,
Yeah.
is Tirzepatide basically like pressing two important buttons at the same time? One for GLP-1, one for GIP, helping manage things after a meal, but maybe in a more coordinated way.
That's actually a really good analogy. Yeah, think of GLP-1 and GIP as maybe two conductors leading different sections of the body's metabolic orchestra.
Okay.
For a long time, therapies mainly focused on boosting just one conductor, usually GLP-1.
Right, the GLP-1 agonists.
Exactly. Tirzepatide, though, it comes in and gets both conductors working together, creating this more powerful, more harmonious metabolic response. And it's not just, 1 + 1 = 2. It seems to be synergistic.
Synergistic.
Yeah.
Meaning the combined effect is greater than just adding the two individual effects together.
Precisely. The combined activation gives you a response that's bigger and maybe better balanced than activating either pathway alone. It's tapping into the body's natural systems, but giving them this enhanced, sustained push.
That's really interesting. Not just hitting two targets, but how they work together. Can you walk us through that synergy a bit more? Like what actually happens inside the body when Tirzepatide activates both GLP-1 and GIP receptors?
Absolutely. This synergy is really the key to its effectiveness. So when both pathways are active, several really beneficial things happen, amplifying what your body naturally does after you eat.
Okay.
First off, you get a significant increase in insulin secretion. But, and this is crucial, it's a smart increase. Both GLP-1 and GIP are what we call glucose dependent.
Meaning they only work when blood sugar is high.
Exactly. They tell the pancreas's beta cells to release insulin only when glucose levels are up. This is great because it minimizes the risk of hypoglycemia, dangerously low blood sugar.
Right. That's a big concern with some older diabetes meds.
It is. And what's interesting here is GIP's role. While GLP-1 strongly triggers insulin release, GIP seems to also help keep the beta cells healthy, maybe even helps them survive and multiply over the long run.
Yeah.
So Tirzepatide isn't just pushing the insulin button harder. It might actually be helping to maintain the insulin factory itself. You get a stronger, more sustained response compared to just activating GLP-1.
That's a really important distinction. So more insulin when needed and maybe healthier insulin-producing cells. What else?
Second, Tirzepatide does a great job suppressing glucagon. Glucagon, as you know, does the opposite of insulin. It tells the liver to release more glucose into the blood.
Right. raises blood sugar.
Correct. GLP-1 normally helps suppress glucagon, but the dual action with GIP seems to dampen it down even more effectively. This reduction in the liver pumping out glucose is really important for lowering blood sugar levels, especially overnight or between meals, which can be a real problem in type 2 diabetes.
Okay, so better insulin response, less glucose production from the liver. What about digestion and appetite? That's a big part of the story too, right?
A huge part. Third major effect is slowing down gastric emptying. This is mostly a GLP-1 effect. It reduces how fast food leaves your stomach and enters the small intestine.
And why is that helpful?
Two big reasons. One, it helps smooth out those big blood sugar spikes you can get after eating, makes control much more even.
Mm-hmm.
And two, because food stays in your stomach longer, it sends signals to your brain telling you that you're full. This really ramps up satiety and reduces appetite.
Ah, so you feel full sooner, stay full longer.
Exactly. Which, as you can imagine, is incredibly helpful for reducing how much people eat and for achieving weight loss that actually lasts.
Makes perfect sense. Is there a direct brain effect too?
Yes, that's the fourth point. Both GLP-1 and GIP act directly on appetite centers in the brain, like the hypothalamus. They basically turn down the hunger signals and turn up the I'm full signals.
Okay.
With tirzepatide hitting both pathways, these brain signals seem to be much stronger and last longer compared to just GLP-1 drugs. People report fewer cravings, less desire to eat. There's even some thought it might affect the reward pathways related to food, making certain foods less appealing.
Wow, that's tackling appetite from multiple angles.
It really is. And finally, beyond just sugar and weight, we see broader improvements, a better overall metabolic profile.
Such as?
Things like lower LDL cholesterol, the bad kind, lower triglycerides, and sometimes even a boost in HDL, the good cholesterol. Plus, some studies show reductions in inflammation markers.
So it's not just isolated effects. It seems to be improving the whole metabolic picture.
Exactly. It suggests a more systemic recalibration is happening, not just treating one symptom. It's a really comprehensive effect.
That is incredibly comprehensive. It really paints a picture of hitting multiple points in that metabolic dysregulation pathway.
So you mentioned it's a synthetic peptide. How is tirzepatide actually built, chemically speaking, to allow it to do all this and last in the body?
Ah, yes, the molecular engineering is quite clever. Chemically, it's a chain of 39 amino acids. Its basic structure is actually inspired by the natural GIP hormone, but it has some key modifications.
Okay.
The sequence of amino acids is tweaked to make sure it binds effectively and potently to both the GLP-1 and the GIP receptors. That's the first piece of the puzzle. All right, the dual binding.
But the really ingenious part is the addition of one called a C20 fatty acid moiety. Think of it like a little fatty tail attached to the peptide via a linker molecule.
A fatty acid tail. What does that do?
That tail is the key to its long life in the body. It allows tirzepatide to latch onto albumin, which is the most common protein floating around in our blood.
Ah, like hitching a ride.
Sort of, yeah.
Yeah.
But it's more like putting on a protective disguise. Binding to albumin shields it from being broken down quickly by enzymes in the blood, especially an enzyme called DPP4, which normally chews up natural incretins like GLP-1 and GIP in just minutes.
Okay, so the tail protects it from breakdown.
Precisely. And this protection extends its half-life, the time it takes for half the drug to be eliminated, to about 5 days.
5 days? Wow.
Yeah, it's quite long. And that's what makes the once-a-week injection possible and practical for patients. You get this sustained, steady signal activating both receptors all week long from just one shot. It's really a combination of understanding the biology and some very smart drug design.
It really is impressive engineering. Now, let's step back a bit. The idea of using incretins for diabetes isn't brand new. Can you give us a little history? How did we get from knowing about GLP-1 and GIP to actually developing this dual action concept?
Right, the history is important context. Scientists have known about the incretin effect for a very long time, basically, noticing that eating glucose triggers a much bigger insulin response than injecting the same amount of glucose.
Suggesting something from the gut was involved.
Exactly. By the 80s and 90s, GLP-1 and GIP were pinpointed as the main players. This led, eventually, to the first generation of incretin therapies in the early 2000s, the DPP4 inhibitors, which stopped that enzyme from breaking down natural incretins, and the GLP-1 receptor agonists.
Like exenatide, liraglutide.
Oh.
Those names might be familiar to listeners.
Correct. Those were game changers themselves. They improved blood sugar, and the GLP-1 drugs often help with a bit of weight loss, too. They really proved the incretin approach worked.
So they were focusing mostly on GLP-1 back then.
Primarily, yes. There was this lingering question, though. Were we missing something by only focusing on GLP-1? GIP, for a while, was kind of the forgotten incretin in diabetes.
Why was that?
Well, some early studies in people with type 2 diabetes suggested GIP didn't boost insulin quite as well as it should. This led some people to think maybe it wasn't a useful target, or maybe its role changed in diabetes. So, for quite some time, GLP-1 really stole the spotlight.
Interesting. So despite GIP being somewhat sidelined, what sparked the idea, the hypothesis, that actually targeting both might be better? That seems like a bit of a leap, especially if GIP's role was questioned.
It was a leap, and a really crucial one. This happened around the early 2010s. Researchers, especially the team at Eli Lilly, started thinking differently. Maybe GIP's reduced effect in diabetes wasn't a reason to ignore it, but maybe a sign that restoring its action alongside GLP-1 could be beneficial.
Kind of like maybe GIP needed GLP-1's help to work properly in that disease state.
Something like that. The hypothesis was that activating both receptors together could lead to synergistic effects. Maybe GIP could help beta cell health in ways GLP-1 couldn't, or affect fat tissue differently, complementing GLP-1's known actions.
So complementing each other.
Exactly. It was a bold idea, kind of going against the grain a bit. It required developing a molecule that could actually hit both targets effectively. Eli Lilly pursued this dual incretin concept, developed Tirzepatide, and they filed a patent for it back in early 2016, specifically for blood sugar control. That really signaled their belief in this novel strategy.
A real shift from just mimicking one hormone to trying to orchestrate two.
A big shift, yeah, moving towards managing multiple pathways.
So from that hypothesis and the early patent, walk us through the clinical trial journey. How did tirzepatide go from concept to getting the green light from regulators?
Well, that journey is always intense, but tirzepatide moved impressively fast. After promising results in early lab and human studies, it went into phase 1 and 2 trials to check safety and find the right doses.
Standard procedure.
Right. But the results were so good, so encouraging, that it led to the launch of a really massive phase 3 program called SURPASS, starting around 2018.
Okay.
This was a huge global effort. Multiple large trials, SURPASS 1, 2, 3, 4, 5, and others. They tested tirzepatide in all sorts of scenarios by itself, added to other common diabetes drugs like metformin, and even head-to-head against other strong treatments like semaglutide and long-acting insulin.
So really putting it through its paces.
Absolutely. And the data that came back trial after trial was just remarkably consistent and positive. Across thousands of people with type 2 diabetes, tirzepatide consistently lowered HbA1c, that measure of long-term blood sugar and body weight, more effectively than the comparison treatments, often by quite a significant margin.
Unprecedented results, basically.
And were used in many publications, yeah.
Unprecedented. This strong evidence package was submitted to regulators in 2021. The FDA saw the potential, gave it priority review, and approved it in May 2022 as Mounjaro for type 2 diabetes. That initial approval was based on 9 big trials with over 7,700 people. A huge amount of data.
Massive. But then the weight loss effect was so striking, even in the diabetes trials, that it led to a whole separate program focused just on obesity called SURMOUNT.
Ah, okay, for weight management specifically.
Exactly. The SURMOUNT-1 trial, in particular, studied people with obesity but without diabetes. And the weight loss results were, frankly, astonishing. This paved the way for another FDA approval in late 2023 for chronic weight management, this time under the brand name Zepbound.
So 2 major approvals relatively quickly.
And then a third. Showing its broader metabolic impact, it was approved in December 2024 for treating obstructive sleep apnea in people with obesity. So, yeah, a really fast and successful development path driven by those consistently strong results.
That is quite a trajectory. Now, to really nail down its place, how does tirzepatide truly stack up against those earlier incretin drugs, especially the GLP-1 agonists like semaglutide that people might know? What are the core differences driving that superior performance we saw in trials?
Right, it's key to differentiate. While they're related, tirzepatide is a definite step up. The absolute #1 difference is the dual versus single receptor activation.
We keep coming back to that.
Because it's fundamental. Older GLP-1 drugs only hit the GLP-1 receptor. They do a good job lowering blood sugar, sometimes helping with weight, reducing cardiovascular risk. But tirzepatide activates both GLP-1 and GIP receptors. And that combination, that synergy, just seems to unlock a more powerful overall metabolic effect.
Okay, dual action is key. Any other differences?
There's also a subtle difference in their chemical origin. Most GLP-1 agonists are designed based on the GLP-1 hormone structure. Tirzepatide, interestingly, is built on the GIP hormone sequence as its foundation, but it's cleverly modified so it also hits the GLP-1 receptor strongly. This different starting point might contribute to its unique profile.
Interesting structural difference.
And then ultimately, the proof is in the pudding, right? The clinical efficacy. We have head-to-head studies like the Surpass-2 trial, which directly compared tirzepatide to semaglutide, a very effective GLP-1 agonist.
And what did that show?
It showed tirzepatide was superior. Patients on tirzepatide had significantly greater reductions in both HbA1c and body weight compared to those on semaglutide. It wasn't just a tiny bit better, it was a clinically meaningful difference, often an extra 0.3 to 0.5% drop in HbA1c and several extra kilograms of weight loss, depending on the dose. That kind of direct comparison really solidifies its position as, a next-generation therapy.
So it's like the older drugs were a great specialized tool, maybe like a powerful wrench, but tirzepatide is more like an advanced multi-tool. It combines the functions of both GLP-1 and GIP into one device, giving you more options and power.
That multi-tool analogy works really well, actually, yeah. It's not just a slightly improved version of the old tool, it's a different kind of instrument altogether, designed to tackle the complexity of metabolic problems more effectively by leveraging both systems. That synergistic boost is why it's seen as such a big step forward.
And those clinical results really drive that point home. Let's talk about that wow factor, again, the actual numbers. Can you give us a bit more detail on just how impressive the blood sugar and weight loss results were in those Surpass and Surmount trials?
Yeah, the numbers really are striking and explain the excitement. Let's start with blood sugar control, the HbA1c reductions.
Okay.
Across the Surpass trials in type 2 diabetes, the average drop in HbA1c was between 1.7 and 2.4 percentage points.
That sounds like a lot.
It is a lot. Getting a 1% drop is considered very good in diabetes management. Getting over 2% on average is exceptional. And even more telling, on the higher doses, somewhere between 91% and 97% of patients actually got their HbA1c below the key target of 7%.
Wow, almost everyone hitting the target.
An incredibly high proportion, yes. That's a huge win for reducing long-term complication risks.
Okay, that's blood sugar. What about the weight loss numbers?
Equally, if not more, impressive. In the diabetes patients' Surpass trials, weight loss ranged from about 5 kilograms up to 15 kilograms. That's roughly 11 to 33 pounds. Again, very significant, especially for people with diabetes who often struggle to lose weight.
Yeah, definitely. And for people without diabetes in the Surmount trials.
That's where it got really dramatic. In Surmount 1, people with obesity but not diabetes saw average weight loss of 15% to 21% of their starting body weight over 72 weeks.
15 to 21%.
Yes, and on the highest 15 milligram dose, the average loss was over 20%.
So just to make that concrete,
Yeah.
if someone started at, say, 230 pounds, like many battling obesity do, over 20% loss is getting close to 50 pounds.
That's exactly the kind of transformation we're talking about. Average losses of 40, 50 pounds or even more were seen in that trial population. It's truly life-altering weight loss for many, impacting mobility, joint pain, energy levels, confidence, everything.
Absolute changes the game.
And beyond just treatment, there's prevention. A follow-up study showed tirzepatide slashed the risk of progressing from prediabetes to type 2 diabetes by 94% over 3 years.
94% reduction. That's incredible for prevention.
It really is. Offers a real chance to change the trajectory for millions at risk. So yeah, when you put the HbA1c and the weight loss together, these results are among the best ever seen for a single medication in these large trials. It fully explains the wow.
No kidding. And it makes sense then why the interest goes beyond just diabetes and obesity. You mentioned sleep apnea, fatty liver.
Yeah.
It sounds like its impact might be much broader metabolically.
You're spot on. The success has triggered a cascade of research looking at its potential across a range of related conditions. It seems to have these systemic benefits.
Okay.
So obesity management is obviously huge now, treating it as a disease in its own right, both in people with and without diabetes.
Right.
Then there's NASH, or MASH, that serious fatty liver disease. It's tightly linked to obesity and diabetes. A phase 2 trial showed tirzepatide could clear up liver inflammation and fat without making scarring worse, which is a critical goal.
Why would it help the liver specifically? Is it just the weight loss?
Weight loss is definitely a big factor, but there might be more direct effects to improving how the liver handles fat, boosting insulin sensitivity right in the liver, maybe even reducing inflammation directly. Larger phase 3 trials are ongoing to confirm this, but it could be a massive breakthrough for liver disease.
That would be huge. What about the heart?
Cardiovascular health is another major focus. We know diabetes and obesity dramatically increase heart attack and stroke risk. While the improvements tirzepatide causes in weight, blood sugar, blood pressure, and lipids all point towards heart benefits.
You need the big trials to prove it reduces actual events, right?
Exactly. So large cardiovascular outcome trials like Surpass CVOT are running right now to get that definitive answer. If positive, that would be another enormous confirmation of its value.
Makes sense. Anything else on the horizon?
Well, besides the recent sleep apnea approval, researchers are looking into areas like polycystic ovary syndrome, PCOS, which often involves insulin resistance and obesity. And there's a lot of interest in combination therapies. Could pairing tirzepatide with other new drugs give even better results?
The research is really branching out.
It really does sound like it's not just tweaking one thing, but more like fixing some fundamental wiring in the body's metabolic system. And because that system is healthier, you see improvements in the liver, the heart, sleep, all these connected areas.
That's a great way to put it, Alex. It addresses the underlying metabolic dysfunction and the benefits ripple outwards. It reinforces that these aren't always separate diseases, but often different faces of the same core metabolic problem. Fixing the root cause can have widespread positive effects.
Which brings us to the future. The current results are amazing, but science never stands still. What are the next big questions? Where are the research gaps? And what's next for these dual or maybe even multi-agonist therapies? Yeah, it's a super exciting time, but definitely still questions to answer. One key area is long-term data. We have solid results over a few years, but we need to understand the effects, both benefits and any potential rare side effects over 5, 10, maybe 15 years. Sustained benefit and long-term safety are always paramount.
Right, the long view.
Then, as we just discussed, confirming the cardiovascular outcomes with hard data from those ongoing trials is absolutely critical. Does it definitively reduce heart attacks and strokes? That's a huge piece of the puzzle still being put together.
Okay, what else?
Another really hot area is seeing how tirzepatide compares to the next wave of drugs. Its success has spurred development of even more complex molecules. We're talking triple agonists, maybe hitting GLP-1, GIP, and glucagon receptors or other combinations. How will tirzepatide stack up against those? That will be fascinating to watch.
Wow, triple agonists. The complexity keeps increasing.
It does. And researchers are also still digging into the dual pathway concept itself. Are there other conditions where hitting both GLP-1 and GIP might help? Can we fine-tune the balance of activation for even better results in specific patient groups? There's still a lot to learn about optimizing this approach.
So looking at the bigger picture, what does tirzepatide's success really mean for the field of metabolic science? How is it changing the way researchers and doctors think about and treat these conditions?
I think its implications are massive, honestly. It's truly revolutionizing therapy. It proves that getting a deeper understanding of our complex hormone signaling can lead to dramatically better treatments. We're moving beyond just targeting one symptom or pathway.
Towards a more systems-based approach.
Exactly. It hammers home that metabolic health is a network. It's not just one hormone or one organ. It's about the interplay between many signals. And fixing problems in that network might require interventions that address multiple points, like tirzepatide does. It's also shifting the paradigm in drug development. The success here strongly suggests that hitting multiple targets, especially synergistically, is likely the future for treating complex metabolic diseases. It encourages a more sophisticated approach.
Right. And you mentioned it made people rethink GIP.
Absolutely. That's a huge implication. GIP was sidelined for years, remember? Tirzepatide proved that combining GIP with GLP-1 action was incredibly powerful, way more than expected. This has totally reinvigorated research into GIP itself. What exactly does it do in fat, in bone, in the brain? Could it be a target on its own or in other combinations? It really forced a re-examination of old assumptions.
Fascinating how one drug can change the direction of research like that.
It is. And ultimately, looking ahead, drugs like tirzepatide offer real hope to significantly reduce the burden of these widespread chronic diseases: diabetes, obesity, fatty liver, heart disease. Its approvals across multiple indications already show its potential impact on public health globally.
It really sounds like tirzepatide isn't just a single breakthrough drug, as impressive as it is. It's more like a proof of concept that's pointing the way forward for metabolic medicine, showing the power of hitting multiple pathways and opening the door for maybe even more advanced therapies down the line, like those triple agonists you mentioned. A whole new frontier, really.
That sums it up perfectly. It's a landmark achievement, but also a signpost for where the field is heading. Very exciting times.
Well, thank you so much for walking us through all of that. It's such a complex area, but you've made the science, the history, and the implications incredibly clear. Your insights have been fantastic.
It was my pleasure, Alex. Glad to be here and talk about it.
And thank you to all of you for tuning in to this deep dive. So remember, Tirzepatide, what makes it stand out is that dual action, hitting both the GLP-1 and GIP pathways, creating this powerful synergy that's changing the game for blood sugar, weight, and potentially much more in metabolic health. Now, just the required disclaimer. The mentioned products and peptides are not intended to refer to any peptides or products sold by Power Peptides. Products sold are strictly for research purposes and not intended for human consumption. Okay, that's it for this episode. Make sure you subscribe to the deep dive so you catch our next exploration. Until then, take care, everyone.